Hey, hi guys. Good evening.
Hello, good evening.
How was your day? Did you try practicing what we discussed yesterday? If you have any problems, we can start with the problem that you had from the last session, and then we can start for the today's agenda.
So, Amit, I actually tried what we discussed yesterday. So,
Mm-hmm.
I have a question on similarity scores.
Okay.
So, when we write down model dot similarity embeddings, and
Mm-hmm.
then we passed we pass embedding twice, right? So, I don't understand why you have to pass the same variable twice in the method.
Same variable twice.
Yes.
Mm, Okay, I don't think I quite understand that.
So if you can pull
Yeah,
out the code that we discussed.
just pulling up.
So if you
You are
go to
referring
similarities, yes,
this?
similarity model dot similarity, yes.
Okay.
Embeddings is we are passing it twice, right? So I
Mm-hmm.
don't understand that part. Why you
Okay.
have to pass the same variable twice?
Okay, so you understood that we have one metric which has embedding for three different elements from our
Right.
current example, right?
Correct.
So now
Yes.
I want to compare the embeddings of each statement or each element in this particular array of embeddings with itself. That's why I was coming up with the um, I can scroll there. You see this matrix because I was putting it like 1, 2, 3, and 1, 2, 3, comparing all of them together. One with one, one with two, one with three, then two with one, two with two, two with three,
Okay.
right? That's
So
why I'm putting it here. Otherwise, I can just put sentence one similarity versus sentence two similarity. I can do that as well. So it's like whatever you are comparing, just put the list of embeddings that you are comparing. So my first list has three element. The three element is okay. So now you are comparing these three element from the given list with the next three element, whichever you are passing in the
your voice
second.
is not audible. Hello.
Am I not audible? Hello? Hello?
Yeah, I can hear.
Okay. Thanks for confirming. So you got it, Saswat? Why we are putting it like two times? So it's like, let's say you have a list of sentences, which is like sentence A, sentence B, and sentence C, right? This is a list of statements which you are trying to do the embedding for. And you get the embedding list of embeddings like you are getting here, right? So now this embedding object will have a list of list where you have sentence 1, 2, sentence 3, right? So you will have this kind of output in your embedding object at the moment. And when you are comparing it with self, it's like you are putting one time in the row and one time in the columns, and then you are making the comparison. Does this make
Okay.
sense?
Yes.
Yeah,
And
that's
my
why.
second question is
Yeah.
the output of similarity scores, right?
Mm-hmm.
Can't it be stored in a double dimensional array directly? Why we have to use the tensor here?
No, it is just how you are
Why?
viewing this. You are viewing it is in the form, you are
Okay.
consuming it in the form of data. When you are comparing one vector with another vector, you are getting a similarity score which is always between 0 and 1.
Right.
maximum 1 between 0, right? And when you are
Right.
comparing this,
Right.
you are already making a matrix here, right?
Right.
Matrix of dimension, which is m cross n. In this scenario, our m and n both were same. Our sentence one
Right.
or our embedding, that was one we were passing, that was also of same dimension, and the other was also of same dimension. These both are of same dimension. These both
Correct.
are from same dimension. That's why we are getting a output matrix which is of same, like 3 cross 3 in this scenario, right? If we
Right.
had embedding this one of four, let's say four vectors were there in this, and then this the second element had three vector, right? So then it would be 4 cross 3
Right.
metric in the output. But internally, you are comparing one sentence with other sentence at a time, and you are getting the output which is between 0 and 1 always. For cosine similarity,
Okay.
it is always between 0 and 1, 0 being most distant and 1 being completely overlapping,
Closest. Right.
closest. Yeah. Does this make sense?
Yes. Yes.
Mhm. Okay. I have uploaded these notebooks on the GitHub. You can take a look. Someone wants to practice, you can take it from there. I have uploaded these notebooks already on the GitHub.
Can you please share the link also?
Uh, yeah, just give me a moment. I'll put it in the chat. And anyone, any other issue, or else we can get started. And why do we have only 4 people today? Is it some sort of holiday or something? No worries, we'll get started. We have a lot to cover today. It will be fun. I have shared the GitHub link in the chat. You can you can get started from these basic notebooks. Okay, so we can get started, but before we get started, I want to know how you guys are feeling. How are you enjoying the learning? Is there anything that I should improve upon? Maybe something on the explanation part or something. We can take that definitely, or else we can proceed further. Only Shashwat is feeling good. How about rest of the guys? Tamshir?
No, I think everything is fine, but um, when we do a project, then we will understand. But what I feel, after seeing the assignment, that the assignments are quite different from what we are learning. That
Okay.
means if I have to done any say one single assignment, I have to go through the Google Chat GPT and learn it, which is kind of
Yes,
what we learning from the lectures. It's just a 15-20% only what we need to
correct.
work on the assignment side.
Exactly. You got the right point of it. So the idea is I'll be able to help you understand the workings of it, right?
Yeah.
We have discussed the theoretical part, how internally things are moving from one step to another step, some terminologies. If you directly jump into the code without understanding these terminologies, you might need not understand what is happening there. But now, if you go to Google or if you go to ChatGPT and you get a code and it explains you the code, you will be able to understand what it is referring to, right? Second point,
Yes.
we don't have enough time if we can go deep into each and every detail of everything and cover all the points, right? The idea is to give you understanding you so that you can get started with, and definitely you need to put efforts to understand the advanced concept behind all of it, right? So the assignments are, if you want to do, you need to really work on that, and you need to do some research, maybe take help from ChatGPT, but take help, make sure you are also understanding what it is producing for you.
Yeah, that's why I submitted 3 assignments,
Great. Yeah.
from the Gen AI
Hmm.
foundation lecture. There are the five in which I take help from GPT and the code, its
Ah,
code also, but understand
yes,
how the
exactly.
tokenizer has been the tokenizer or model has been created, and then how we
Mm,
put tokens strings into a token, and then we
great.
evaluate the system and everything. So
Yes.
it will take time, but I know that it will take time because the
Mm,
code has been written, everything,
mm,
understand how the things are, because there are so many methods in the every framework and the model itself. So it will
yes.
take time.
Yes. Good start, Shamshir. Maybe you guys can collaborate and work in group so that you can all learn together. That can be also a good idea. And yeah. Uh, okay, so we will start for today. Uh, Whenever the rest of the folks will join, they can start from there itself. I'll start now, right? So yesterday we have discussed, we have seen the working of transformers. We have gone through some sample code as well, how the transformer or how we can use the transformer for our use cases. But transformer are not that advanced, not that great in terms of the use cases, right? If you give a complex task to the transformer, even when you are doing the text generation part, they were not doing very great, right? They were sometimes repeating the same words multiple times. They can do that. So there are some limitations when it comes to the transformers, but they are the building block when it comes to any other language model, right? So now we have
Yeah,
since
after doing three assignments, one few things I understand that the steps which we need to follow is like create a tokenizer, then create a model, then get the tokens, get the tokens from the sentence or a group of sentence, the list of the sentence that we have to get it. Then we have to get the inputs, inputs ID we need to get it, and then attention mask, and based
Mhm.
on the model we get the output what
Correct.
will whatever that
Yeah,
will.
that's the standard path for a transformer while
Yes,
it is
yes,
working, right? Yeah. So moving further on this, if anybody has any question till now, we can take it up now. Rest, I will take the some any of the doubts which are in our session later. But I'll
yeah.
get started with the next topic, that is fine-tuning techniques that are available for our large language models, right? So till now, we were of the understanding that how transformers are working, how internally the tokenizer is working, decoding is happening, it is going through all the iteration, epoch, and everything, right? Now for fine tuning, what is the purpose of fine tuning, or why do we need fine tuning, right? We saw how the transformers are working, right? Fine tuning can be of different type depending upon what our use case is at that point of time, right? So fine tuning is like using a pre-trained model to specific task by further training it so that new and specialized data set is the model or the trained model that we have, the pre-trained model is encountered with the new data set so that it understands the new data, it understands the pattern in this new data, and it is able to uh, produce the result based on whatever the fine tuning we are doing for that particular scenario, right? So that's the whole agenda behind fine tuning. What are some of the common techniques? Is like you can simply expose your data by labeling properly. One of the biggest, I would say, intensive task, apart from resources in terms of GPUs or let's say hardware, is data. What data you want to train this model on, right? So you should be having a proper input and proper output. If you do not have a proper input and output, it's like garbage in and garbage out. So you need to have a proper uh, mm, labeled data for this kind of scenario. And the quality of data really matters here. It is not just you can randomly put anything. It can be a domain specific, it can be a subject specific, it can be any particular use case specific that you can have, right? But this data is the most critical thing when it comes to fine tuning of a particular model, right? Some of the techniques that are very common when you are coming across fine tuning the model is like you just take the data and you put when you say human preference like RLHF that we have discussed earlier also, this is reinforcement learning with human feedback. It's like the model is predicting something and the human feedback goes in. It's not like that human is sitting and validating whether the output has come. It's like going in real time. It's like you are giving 1,000 input to the model and it is you are the model is predicting something, and then you take this data set, go for a human validation, whether this output that the model has generated, whether it was correct, whether it was not correct, right? And we take this input from the human and we feed it back to the model, and model understands, okay, this was the award that it has got, this was the penalty that it has got for this particular generation, and it needs to adjust accordingly, right? So that's the simplest way of fine-tuning a model. In this particular scenario, weights and biases of the models of the internal neural networks are updated throughout the iteration. Whenever we are doing this kind of treatment, this kind of training, basically the weights and biases are updated of the model. The model remains of the same size, everything remains the same, right? But when it comes to other kind of fine tuning like PEFT is parameter efficient fine tuning. So currently in this particular scenario, we have models which has, let's say, 70 billion parameters. And when I say these parameters, these are the internal neurons, internal nodes inside that large language model neural network, right? So fine tuning these many nodes can be very resource intensive, right? Let's say you have very less data, and you do not have uh, too much of resources to invest in as well, but you want to fine tune your data. So what you can do is, this PEFT is one of the efficient technique when it comes to fine tuning of the model, right? What happens in fine tune currently in RLHF, what you are doing, you are processing the data, you are passing the data through whole the layer of your large language model. But in parameter efficient fine tuning, you are updating only certain layers of your language model. Rest of the model remains the same. Let's say you have a model. Uh, just a moment. Yeah. Let's say you have a model which has 1,000 layers. Let's say these are like 5,000 layers in line, right? So rather than updating or passing it through all the layers, you are freezing top, let's say 900 layer, and you are updating the weights for just last 100 layers, right? From 1,000 layers, 900 layers remains the same. 100 layers, you are passing it, updating it, and making sure that the weight is updated, right? So it's like you are not updating the whole neural network, you are just updating certain part of that neural network, and you are storing that weights, the updated weights from that neural network, right? So that's how it goes. So this is like LoRa. This is low rank adaptation for your neural network. In this, what happens is, let's say you download a model from Hugging Face. If I take a scenario in this particular scenario, take example in this scenario, download a model from Hugging Face, right? Let's say this model was of 1.3 GB. This is a pretty small model. Let's say you are taking some Distilbert model or some older model which is of relatively smaller size, right? Then you take your data which is properly labeled, properly as per the model. So let's say if the model was trained on text data, and then you are, for fine tuning, you are putting in image data, right? That is again conflicting. So you need to make sure that the model follows the data that you are providing, or let's say the data is in the shape and format which can be used for training for that particular model, right? So it is not just that you can put any data, any random model. You need to take care of all that scenarios. The data has to be clean, the data has to be processed, the data has to be labeled. The data quality really matters here in this particular stage. And then you update the weights and biases, and let's say the weights that end up the weights and biases and the parameters that you are updating in the neural network, they are again 23 MB. And yes, they can be this small, that you are updating the weights and you are storing these weights separately. So and you can push this back on your Hugging Face. So what you will have the base model plus your updated weights. These two will be in your Hugging Face, right? So it's like you are using the pre-trained model, and then you are adding your weights based on the training, based on the updation, whatever the things you are doing, and then you are uploading it back on the Hugging Face up, so that you can use it, or you can make it public, or you can do whatever you want to do. Example for this can be, there are multiple model or multiple derivatives. In this scenario, we can call it a derivative. Let's say this base model was my llama model, right? Llama model, let's say 7B model or 70B model or any model. And then you download it and you fine tune it for your specific use case. Let's say you tune it for your classification, right? And then you put it back. If you look into the Hugging Face, you will see this kind of example, like a lot of the models are derived like this only. And they will explicitly mention that this is trained model on this data set and the base model was this, and it can be for your use case. Let's say you want to just consume your classification model. You have just a problem statement where you need to classify. You just need to search for which model is best trained, or where your training data, this data was closer to your expectation, right? So that is my low rank adaptation. When it comes to quantized low rank adaptation, it's like you are reducing the size of the model. Earlier you had, let's say, 64-bit model. Now you are reducing it to, let's say, 8-bit model. You are actually, it's similar to let's say you have a 4K video, or let's say a photo which is of 23 MB, 50 MB, right? And you are reducing the quality of that model without compromising on too much of the accuracy, and you are scaling it down so that you can have a model which is of smaller size. That is what my quantized version of my LoRa, right? These two techniques are quite popular in the industry, and especially the quantized one, because we are trying to reduce the size of the model. If we reduce the size of the model without compromising on the accuracy part, we can have like scaling would become, or the adoption by majority would become easier, right? No, everybody cannot afford to have 4090, right? 4090 is a GPU, or like nobody, or like everybody cannot have um, um, super fast hardwares, right? So that's where my this kind of technique, or these kind of fine tuning techniques comes up, are really helpful. Other one can be like the prompt tuning. It's like the how you ask your question. The model response can change based on your how you ask the question from the model, and that is simple like prompt tuning, right? So this is some of the basic example of how, and these are the different techniques of fine tuning the model. If we can broadly classify, there can be others as well, but these are the broadly, and these are most common out there in the industry at the moment. Tomorrow there can be some other techniques also, but these are currently what we have at the moment, right? Any questions in at this point of time?
Can you please reiterate LoRa one more time?
Sorry.
LoRa.
Okay. So in LoRa, you are not you are optimizing the parameters that you are fine tuning for your use case. You are not fine tuning everything. Only you are tuning certain. Let's say your model can have 70 billion parameters, but you are training only 10% of those parameters, right? So if you are training only those 10% of your parameters, then your resources, or let's say GPU, or the data that would be required to tune your model, right? That would be significantly lesser, and you can expect the performance, because these are certain layers which will be responsible, or these will be updated for your use cases, right? So you are manipulating the weights, you are manipulating the bias of the neural network for your use case, for the certain layers only. Let's say 10% of the layers only. Okay.
Just a top-up question, like how we identify like which of the parameters we have to fine tune. Can you just give an
Okay. Okay. So if you find, let's say your model had around, let's say, 1,000 layers, right? As in our previous example, you have 1,000 layers, right? Your input that is coming from here, uh, it will be multiplied with certain weights, certain biases, certain activation function. It will pass through here, right? So passing my model, passing through it, all the layers in the initial stages will not have significant impact compared to when you're, or and let's say if you, even if you do, your whole process is going to get impacted, right? So what if you just tune your last layer, you update the weights, or not just the last layer, like only the, let's say, single layer, let's say last couple of layers of your neural network, so that whenever your input is coming, it is going to channel through these layers only, and you are updating the weights. You are let's say making your model bias towards the data that you are putting in. If I can put it in easier language, you are making your model bias, so the last and layers towards the end, towards the output. And when I say towards the end, that means towards the output, the layers towards the output are updated.
okay. How we decide like which of the activation function we used for fine tune the model? Like how we decide which?
That
Acquisition.
depends on the use case. So we have seen in our earlier example that we were using the softmax activation function, right? So depending upon your use case, let's say if your use case is to classify, right? Let's say your classification is 0 and 1 only. You might want to use softmax function. But let's say if your use case does not have this kind of like the output, your output that you expect from your data, sentiment, let's say your use case was sentiment analysis. So there, this kind of activation function can, so depending upon completely on your use case, it's not something that goes as one size fit all kind of scenario. Output of the model will always be probability. There will be certain probability 0.5, 3.9, minus 0.6, right? Minus 3.4. These will be all probabilities that will be there in your outer layer. Now, depending upon your activation function, your output will be provided.
Okay, and one more thing, like, is transfer learning and fine tuning are the same thing, or if not, then how it is different? Like,
Okay, transfer learning is your pre-trained model, right? You have a pre-trained model which is already trained on a bunch of data, right? You are using the learning that it had already accumulated while it was training, and that's what we call them a pre-trained models. They have some learning from their initial scenarios, and now you are transferring that learning, adding some additional layers over that learning so that you can make the use of the learning that it had earlier. The example that we have discussed earlier as well. Let's say you have a model that was trained to predict the model was trained to predict the cat, right? The image of cat. And now you want to make sure that it also predicts the dog, right? You don't want to predict the cat now, you want to predict the dog. So taking the learning that it had while identifying the cat, you take the learning that it is able to identify features, right? So initially, the pre-trained model would have, okay, I need to identify feature, what feature can be there. Once you can identify the feature, then you can match those feature with some other features like that can be of cat or that can be of dog, right? So this identifying the feature, this is the learning that you are transferring for other use case, right? Whether it is for cat or dog or for any other scenario. So in this exactly here also, your model is learning to predict the next token, right? Here already your model is learning to predict the next token, but you are making it learn to get biased in a certain scenario, in a certain fashion, right? You want to get it biased towards your use case. Sometimes, let's say you have a use case where you want to fine tune it for, let's say, code generation, right? You want to have a Python code or JavaScript code or HTML code or any other kind of code, right? Or second, you can have, just give me a moment. Yeah. Second, you can have, let's say, you can fine tune your model for, let's say, medical use case, right? So depending upon your use case, you are biasing that model. You are making learning using the learning of the model that it had while it was learning to predict the next token. That learning you are using and then taking it further.
like
Make sense?
yeah, but like fine tuning and the transfer learning are both fall into the like similar into the one class. Like, so how we decide like we need to use the fine tune or we have to use the transfer learning, because in the fine tuning we freeze some of the layers and after that we update the layer, but in the transfer learning we are using all the layers and on top of that we are train the model. So how we
Mhm.
decide like our model is not biased, we have to use the fine tune or we have to use the transfer learning in that?
No. So transfer learning is the initial stage. You use the transfer learning over and above, you use the fine tuning of the model. You don't want to train your model from the scratch, right? You are using the pre-built model which is trained. You are using the learning of that model, adding your features, adding your biasness on that model, and then using it. It's not that either transfer learning or fine tuning. You are using first uh, transfer learning and you are accumulating or you are adding your fine tuning parameters, biasness over that learning that it had, passing it through the layers, biased layer for your use case, and then you are consuming it.
This unlike the classical machine learning models or new deep learning models.
Mm-hmm.
These LLMs have different structures. So the last layer means what? You are saying that the layers are last layer is getting fine tuned. So normally this encoder decoder construct we have, correct? So
Mm-hmm.
where we will be fine tuning in between this maybe these are
No,
a
so
totally different type of structure compared to the classical layers, right?
uh-huh. So the encoder decoder kind of architecture was there in our transformer. For GPT models, it has come up. It is only the decoder. So we are only tuning these layers, these all layers that I am referring to. These are only the layers of all of my decoders, right? And I am training.
Decoders,
Yeah.
but decoder also see
Mhm.
we pass data as a single all together, right? Normally in this LLMs now, it's not.
Mhm.
So where it will get fine tuned, maybe last layer means you can
layers
visualize or
layers
something.
towards the last. Your neural network can have 1,000 layers, not even 1,000, can have millions of layers. You are tuning only certain 5%, 10% of those layers, and these layers towards the end. And you are storing the weights of those layers that are updated. You can store the whole model also. You can update, store your, for LoRa that particularly that I'm referring to, you stores just the updated weights of those layers. And whenever you are using that model, you accumulate these weights and pass your data through it to get any kind of prediction. Language model is just a prediction of next token. Make sense?
Yeah, I'm still unable to visualize. See, normally we in other cases we know that okay, last layer is a soft max or that kind of layer. So you are saying the soft max get fine tuned for this purpose.
No. Softmax is the layer that is coming into your output, right? The layers
Output, yeah, last.
before that. Yeah. So we
Uh-huh.
have 1,000 layer. We do not have thousand of softmax layer in the output, right? So there are thousands of layer of neural network which are interconnected, right?
Yeah,
So
that's why
we
I'm
are
saying.
updating
Yeah, these
those
all
those.
models are actually passing their output to the previous layer.
Yes.
Like that, the constructor will go. Now it will go to the all the layers. This input of output of the last will go to the all the input, right?
Uh-huh.
The feed forward backward is there now. So that I
Yes.
think. So
Yes.
how do we visualize that which layer get tuned, and then if you tune that. I don't know how alone with the last layer we can optimize it, because when
Mm-hmm.
the data see actually when you do the normal tuning, the
Mm-hmm.
data the data is getting backward, right,
Mm-hmm.
backward to the entire layer, correct.
Yes. Yes.
So here it will not go to the entire layer, only one or two layer the data will be gone back.
Uh-huh. Let's
Now
say
it will
yes, it
be
goes for 1 and 2 layer only, but generally it is like 5%, 10% of the layer that you are tuning. So
yeah
if you
only
have millions
before
layer, yeah,
beyond that the data won't be going back or getting changes.
yes, there won't be any change in the weights and biases that is outside the layers that you are updating in that
But
particular
sometimes
scenario.
it can crash entire system also, right? I think because when
Uh,
you try to fine tune,
mhm.
maybe if some relation is the other functionality when you fine tune for something, something will go bad also, right?
Yes, that can happen. That can always happen. But that's what LoRa is trying to do, right? You do not have too much of intensive. If you want to train your model or find in your model for 1,000 layer, all the models that are there in your layer, there are higher chances that you will need higher compute. Your data, you need a significant amount of data to have an impact on all the
Can
layers.
we do even a small model in our laptops?
You can try. I have not tried it on my
We
local
have a
laptop.
code or something for that.
We
We
can
have any
find.
code?
No,
I'm
we
saying one
can.
GB, 1 GB model or something. Maybe there are
No, so
small models.
if you want to, you can definitely, you can easily find the code of for fine tuning the model over the internet. You can easily get it. You can easily get on YouTube as well. There are multiple tutorials around that. But I have not tried it on my local laptop, and it's up to you
So,
if you want to give it a shot.
Ankit, I have only one question in that.
Hmm.
Let's say we are developing any enterprise application,
Okay.
using a Gen AI.
Okay.
So before can we use this fine tuning technique within a system itself, or if before that, like if I am currently developing any AI based application, so at this time I use fine tuning, or I integrate the fine tuning code, whether using RLHF or any prompt tuning or any technique, okay, which encoded embedded into my code. So whenever the the application is running, it will be the fine tuning will continue work on. Is that we use, or is kind of that just okay, in the development phase we use fine tuning techniques, we fine tune the LLM, and then release the application.
Yes, the second one would be more appropriate because once you fine tune the model, you freeze the weights.
Okay.
You freeze the weights, you freeze everything, all the parameters of your neural network, of your large language model, and then you start the inferencing,
Okay.
right?
So
Because you do not
basically,
want whatever the garbage that it might produce, right? You don't want it to impact the model, right?
right.
The
So
the output
basically, it
need,
is
yeah.
before going for a production, we have to do the fine tuning, and after that we have to just remove the fine tune part from the code base.
No, no, no. So let's say you have, let's say 1000 layers that were there in the original model. And this is just
Right.
an example. There can be millions of layers, right? Let's say you have 1000 layers, right? And then you have, let's say 50 layers of this model, which are, let's say you have tuned and you have freezed the weight of these 50 layers, right?
Mhm.
So whenever you are using this model, you are using this 950 layers plus these 50 layers, and then you are
Yes.
inferencing over it.
Yeah.
So you are using the pre-trained learning of these 950 layers, and then you are also manipulating the response or biasing your response towards the data on which you have trained, and then your output is coming, or you are making that inference.
So
Right? Hmm.
let's say I'll give you an example on that.
Hmm.
There is a gen based application which take the prompt, okay,
Hmm.
and
Hmm.
based on that it create a test file.
Okay.
One
What kind of test file?
it's a feature file in the Selenium, in the BDD framework. It's take create a feature file which takes as in the data from the framework itself, the code base which we have, and the prompt which we have given it.
Hmm.
Okay, so in that case, I need to make it improved. So every time my feature file which is created is more efficient, more reliable. So my human intervention will reduce in
Hmm.
that case. Okay,
Okay.
and using entropy,
Hmm.
Claude LLM by and through the entropy and bedrock.
Okay.
Okay, so that
Uh-huh.
is a thing. So in this case, if I have to uh, work on the fine tune, so the way which you have tell, this is the way I have to do it, or there will be something else we need to do.
No, so depending upon the platform the model is hosted, just like you have model hosted on Anthropic is Anthropic does provide you to download the models, right? I don't think Anthropic provides you. They are providing you the model. You can access those custom models which are specifically tuned for certain use cases. Like there are like in Claude 3.7 Sonnet or something, which is particularly trained to produce code, right?
Yeah.
So
No,
you can.
we are
Hmm.
not creating a code. We are just doing a text to text classification. Like if I am giving a prompt that okay, let's say I give my application, I
Mhm.
as a test analyst I need to write a feature file for login page where my login page have two text box. One is for providing a username, another is providing for a password, and I have a one link which is called as a forget password, which redirect me on a link direct to the page where I have uh, put my reset my password, and the button login button, in which when I click it, it will it will authenticate my credentials and
Mhm.
redirect me on uh, the application. So this is my prompt. So based this prompt, my system, my application will write the feature file. Like, okay, this is the feature file name, this is the one scenario, this is the second scenario, this is the third scenario, and these are the steps of each scenario.
Hmm.
And for these each scenarios, we have a code, we have a framework which has been written, in the cucumber based, selenium cucumber based. So we have integrated it that way that whenever I write it, it will go to the data, the previous data which we have written, the feature files which we have written, to understand those files, and based on that it will create a new feature file.
You can use your input and output, which is labeled, and you have a bunch of such example
Maybe
to
let's
tune
let's
your
let's
model.
we will discuss some later time. Let's not waste other people time with this.
Yeah,
We'll discuss,
great. Yeah,
or maybe even
thanks.
I'll say.
Hello.
Yeah, sure.
This prompt tuning also, we are tuning only the final layers.
No, so this is like you are
We
asking
are
the
giving
model
some
to.
question and we have to get the answer like according to that, right? It would match the match.
Yeah, so
That
it's
way
like
we tune.
how you ask the question, how
Hmm.
you give the context, how you ask the model to structure the response, right? You are also,
Hmm.
this is like you are manipulating how the model would respond, right? This is where the prompt engineering
Yeah,
comes
I'm
in.
asking whether entire layer is getting tuned in this effort
No,
or
no,
only like Laura, we are tuning only the final few layers.
no. So here you are actually modifying the weights and everything of the model. Here you are asking the question or your input in such a way that your output is impacted based on the input directly. And based on the input, as in you, let's say, give example. So your model understand, okay, this is how we need to produce the results, and you are tuning the output for that particular scenario.
So that means entire weights get adjusted.
I won't say adjusted, but the result is adjusted towards the way you have asked.
So that means kind of prompting only. It is what we are
Yes,
done like a rag or some other thing we are
exactly. This is
doing.
like
So
prompt
it is
engineering.
now weight is getting adjusted. Only prompt inbuilt some prompts are written such that it can maybe give a specific type of answers.
Yes, correct. This is like you are
Okay,
adjusting your
it's only
overall
prompting.
response from the
It is
model.
not even a tuning. It's prompt part of prompt
Yeah,
engineering.
you
Yeah.
can call that, but yeah, so adjusting your output is some sort of tuning only. So you are adjusting your output based on the input, that kind of input that you are providing. Basically, prompt engineering.
So how these things are giving you a PDF for a PPT as an output? Okay. So
Uh,
is that anything separately done for that, converting the output into a PDF PPT format?
okay.
There will be some extra programming done after the
Mm,
output.
no. So let's say initially your model was tuned to predict next token, right?
Yeah, text prediction. Yeah, text. It can be a multimodal also where
Yes.
it will predict
Then you
something there
had
also.
model this the same model tuned to generate, let's say, PDF, or to how to generate a PDF. This was trained to the model, right?
Yeah, yeah. How
Then
it will be
how to
done?
create those tables
So the
inside that PDF.
output is a text format, right? So how it will become a PDF or a PPT or it will,
No. So when you write your text and you export it as a PDF, you get a PDF, right?
okay,
So
export. This is an
internally
export
also,
techniques.
yes, the model are tuned in such a way they can write a code, they can compile a code also, and then give you a result. They can directly give you that, or you ask, they will directly give you a table. They will give you directly a
So the
CSV files.
thing is such that first the model will write a code and some other mechanism will take that code and run it and get some output
Convert
and
it to,
export. So
convert
there
it
will
to,
be
let's
two
say,
stages, two or three stages of
hmm,
processing will be there.
yes. So it's like in Pandas data frame, you create a data frame and then you have a method called to markdown. Automatically that data frame converts to a markdown format, or you can convert directly to a CSV. This is how it do it. So you have a document which is ready, it is in text format, and then you convert it to other format the way you want it. There are methods around that, right?
So which model which really help us for time series kind of analysis, the date and time series? Uh,
That there can be different scenarios, but if you are looking for predictions from the model, you might not want to go with large language models
mhm,
because these model can hallucinate, right?
mhm. But some analytic reports, you want to anomaly detection and all.
You can try around that. Maybe you can tune your model in certain scenario. Maybe you can tune your model for root cause analysis as well. But you might not want to rely exactly on what the model has given. Obviously for the initial times, because you might not even know when the model is hallucinating, and that's how the model is that's what the model is trained to do, right? That's up to you what your use case is. That's why the models, even if you want to ask for sales prediction for
So,
next 5 years, they can give you the next
so
5 year sales
still the
prediction.
classical model have importance.
Exactly. That's where classical model are still relevant. The machine learning is never going to go away. There was quite a trade-off between conventional machine learning model versus large language model. But the conventional machine learning model are always going to stay there, because here you have control on the model, what the model, everything that the model is doing, right? And they are specifically built for a use case. They are
Is
not.
there any is there any specific course on this time series analysis from EDIOTA or something?
Uh, I'm not aware of at the moment. Maybe you can browse it through the websites. Yeah.
Yeah.
Okay. Shall I proceed further?
Reinforcement learning is that anyway it is only thumbs up which we give a feedback that based on that it will improve.
Yes. So it's like reward or penalty that goes as a feedback. Okay. Now comes up to our model quantization. Model quantization, as the name itself suggests, the models are typically 30 GB
We
or
have discussed
70
that in
GB.
the previous fine tuning also quantization was there, right? I think that's
Yes. Yes. So it is like you are not tuning the model, you are just quantizing the model so that it comes to the smaller size without hitting much on the accuracy, because hitting on the accuracy is the key thing here. The model size is reduced, the number of parameters are reduced, but the performance of the model remain more or less the same. There are claims in the market. I have not obviously validated all of them, but there are claims that we are reducing the model size by 90% by just a hit of 5% on the accuracy, right? So there are companies around that which are trying to build, but why, first of all, why quantization? Why do we need to quantize a model? Currently, model size can be 30 GB, 70 GB, right? There can be models which are huge. They need huge machine to run those models, right? You need GPUs, you need good amount of RAM for all these calculations that are going to happen in the input, right? But if you have the model which is resource intensive, I call this, the model size is huge in itself, and this is resource uh, intensive. So it is less adopted, right? Because it is too much demanding. You don't want to have a model which is high maintenance, right? You want something which is easily accessible and you can scale it at your own will. Mass can adopt it, right? Because this investment is huge for a lot of companies, right? Not all the companies can have these many resources to run those models locally. So what some other companies are coming up with, they are quantizing these models, reducing the size from 30 GB, so let's say 10 GB, or from 70 GB, let's say 10 GB, without hitting on the accuracy part. If the accuracy was 100%, let's say now the accuracy will be 95 to 97%. This is the whole idea behind the quantization. If you are reducing the size and the accuracy is also significantly reduced, let's say you are reducing the accuracy to 60%. When I say 60%, you mean the comparative. Let's say earlier it was answering 10 out of 10 question. Now it is able to answer 6 questions right? So that's the evaluation parameter. Exactly the same evaluation parameter, exactly everything remains exactly the same, but your model accuracy has reduced. That is not a good way of, or it is not going to help in the adoption, the whole idea of quantization, right? So that's what we need quantization for. That's what we are trying to understand, what is model quantization, right? So it's like model compression technique that converts the weights and activation within the large language model with high precision data representation to a lower precision data representation. So it's like uh, you have 70 GB model predicting 10 correct answers, 10 out of 10 correct answers. Then you have another model which is reduced, the same model reduced to 7 GB, predicting 9 out of 10 answer. That is fairly acceptable, right? So you are adjusting or reducing the size of that model. It's like similar to file compression, right? You compress a file and you share a file, or you reduce the size of an image, or reduce the size of a video, right? You reduce on the quality, but you can still understand what is happening in there. In the obviously the feel and look would be different, but you are reducing and you are uh, able to work around with the compression that you are doing with that file or with that model, right? That's the whole idea behind it. And how it is done, it is reducing the 60 bit or 30 bit. So internally, wherever the calculation is happening, right? So there are some bits inside that, right, which are storing those weights and everything. You are reducing those bit size from 32 or 64 bit to 16 bit or 4 bit also, right? So you are trying to reduce so that earlier your model or the weight was able to store till 0.03456, like these many. Then you are reducing it. Okay, I will store only till 5 digit of my after decimal, right? So that's how you are trying to reduce the weight or reduce the size of your model, right? It makes the model smaller, it increases the scalability, and it is faster inference, because for inferencing you need to load the model. Loading 70 GB model would take much time compared to a loading let's say a 5 GB model or a 10 GB model, right? So it is a faster at inferencing, and the whole idea behind it stays without impacting too much on the accuracy. Accuracy can go down, but it has to be within the threshold or within the acceptable limits. For different scenario, this acceptable limit can vary depending on the use case directly, right? So what are some of the techniques for model quantization? One can be, or let's say if I broadly classify them, this is like post-training quantization. So it's like you have your model, you have fine-tuned your model, your model is like ready to use, you are ready for inferencing, and then you reduce the model size from 64 bit to let's say 16 bit, right? You are reducing post this. So in this kind of scenario, what will happen? Uh, your model accuracy might have a bigger impact, because you are reducing the weight or you are adjusting the weight for your whole neural network. Whatever the fine tuning that you might have done would have a lesser impact now. Earlier, let's say you have a smaller amount of data, you have fine tuned your model and your weights were adjusted. And now you're scaling down all those weights, right? So it can have impact on that part. But the good thing is you are reducing the size of the model, and it is faster. It is less compute intensive, because you are just again reducing the size of the model. You are breaking down the tasks separately. One is tuning your model, and then is reducing the size. This is less complex, less resource intensive, and it is faster compared to my other method, which is quantized aware training. This is like training, or I won't say pre-training, or so it's like while training, you are reducing the size of the model. While training, that means at each node, when the calculations are happening, everything is happening, you are reducing that weight, or you are reducing the quantization, or you are reducing the bit size slowly for that model. That's where you are reducing the bits as well as you are doing all those calculations and everything, and that's why it become more intensive in terms of calculations, in terms of complexity of the network that is inside, right? But it gives you a superior performance when it comes to the comparison with the earlier method. Why? Because in earlier scenario, you were reducing the weights or reducing the size of the model without looking at your tuning, what impact will have it in your tuning, the fine tuning that you were doing. Now you are reducing it slowly with taking care of that your model is also getting tuned, and slowly reducing on the size term. So the performance of your model in this scenario where you have quantized aware training, the model size is reducing with a better accuracy compared to the earlier method, right? So these are broadly, if we
And
classify
how do
them,
you differentiate this PTQ and QAT?
this is how you train your model and how you quantize your model.
So first one you just quantize. Second one you uh, train also, right?
Yes. You're training your model and you're quantizing your model, so that your model earlier it was 70 GB. You are tuning it and you are reducing it the size. And for
So
every
after
layer, you are
training you
reducing it
quantize, or after quantizing you train.
during training. Yes. In first one, after training, we quantize. In the second one, we quantize it along with the training of the parameters.
Okay. Okay.
Yeah, that's why, because we are training as well as quantizing, it
So
becomes
this will
more
be, but
intensive.
that the second one will be very tedious. It is similar to
Yes.
the initial training, right?
Not initial training, but yes, it would be quite complex because you are doing multiple
You
tasks
you
for
need
each
you need
node.
all that data once again, right? Which you might have used earlier, or
Mm,
you will do
No,
in its a specialization.
no, you are just fine tuning your model. The model is already pre-trained. You are fine tuning. You are earlier
With
your
a specific
model weight was
specific
able to
data,
store till 16 digit after the
custom data
decimal.
or specific data.
Huh. Yes. So your earlier it was had after decimal 16 digit, right? For each tuning epoch that you are doing, you are reducing it slowly. Let's say finally you want it from 64 bit, you want it to 32 bit, or let's say 16 bit. So you are slowly reducing the information that is stored after the decimal. Your tuning also, your tuning will have a higher impact in this scenario because you are not just scaling down your weights, right, to the 16 digit or 32 bit quantized, right? You are tuning, you are adjusting the weights and then reducing, adjusting the weight and then reducing. That goes in the proper compute intensive task. But here, your tuning, whatever the fine tuning that we were doing in this particular scenario, will have a higher impact compared to the earlier one, where that is post training quantization.
The first case we are not worried about the accuracy. We just quantize.
Uh, you can say that, but sometimes the first one can be also helpful, where you do not have too much of resources. The accuracy, even if the accuracy, or let's say you want to try which one is doing better, right? You want to
The
go with both of them and see
the
how the
model
accuracy is
we
impacted.
get in Hugging Face and all is what type of model? QAT or PTQ?
They are all pre-trained model mostly. If the model is quantized, then you
No,
can
no,
read the
small,
documentation
lower
and
size,
see.
1 GB, 2 GB, that kind
Mhm.
of models are there, right?
If the
What is the
models
model?
are quantized, you can read through the documentation and see how they were quantized.
But normally it will be QAT or it's PTQ. Normal case.
Completely depends upon who has released them. If you have enough resources, let's say if it is coming from Google or Meta or something, you can expect that they can invest in the resources. They can have, and it is not just that they have tried only one method and come up with the model. Might be they might have tried both the scenarios, whichever gave the higher accuracy, they have used it, right?
Yeah, yeah.
But for that, you need to go through the documentation. Different models can have different type of quantization technique, depending upon the use case completely, right? Then there are some examples of this quantization. These are like these can be categorized back into these categories, but this is something that you might want to explore, and I'll leave it for the for you guys to explore around. Okay? These are like GPT generative unified format where GPU and CPU all are clubbed together. Then we have activation aware weight quantization, just like the QAT that we have earlier, and post-training quantization. I have also provided the link. If you guys want to go ahead and read a bit around here, you can take a look. Okay. Any questions here, or we shall move further?
See, other than improving the accuracy of the model,
Mhm.
maybe what else can come in LLM in the future?
Reducing the size, reducing different use cases.
Ah,
Currently,
yeah,
like for
that are all optimization of what is existing is
you
small
have
size.
reasoning models coming in, right? There
So
can be
what happening inside the reasoning model or thinking model? What is happening extra?
there is a chain of thought that is going in inside. We'll
The
discuss
chain of,
about that when we come there.
okay,
We'll discuss about that. Don't
okay,
worry.
okay.
Yeah. Any questions in here, or we can proceed further? How is everyone silent? No movement in the chat. No one speaking. Are you guys there? Shashwat is there.
Yes, Ankit, yeah.
Mhm. Okay. Are you guys able to understand what we are trying to discuss? And trust me, each and every single topic is of, you can read through this and you can take uh, n number of hours to complete each and every topic. We are talking and we are discussing it briefly, and I'm just trying to make sure that on a broader level, when we come to the use cases that we are going to try later on, you have understanding, the things doesn't go bouncer to you at that point of time, right? Uh, Chalo, let's move forward on this. And here we have model evaluation. How do you evaluate your model? Whether the fine tuning that you have done, whether the model that you are going to pick is something, has it improved in accuracy or has it reduced in accuracy? How are you going to evaluate the performance of the model, of any given model, or maybe across models, right? You have, let's say, a GPT model or a Cloud model or a Llama model or a Mistral model. You want to compare those models. How you can compare those models, right? There are certain benchmarks around that, how you can evaluate, right? So one of the techniques for evaluating is n-gram based. How many of you have worked with NLP, natural language processing? No one? No worries. I'll explain around that. So n-gram is basically how many words, or if I talk in this particular scenario, there are within n-gram, there are bilingual evaluation understanding and recall oriented understanding of gist evaluation, right? So what happens in, let's say, this is particularly, let's say, for the scenarios where you are looking for translation, transformers and everything, they all started with translation of this neural network, translation of the natural language text from one language to another. That's from where it evolved. So let's say you have a statement of 10 words in the input, and your output has again 10 words, right? But, and you also have a ground truth. This is my predicted, and you have something called ground truth, right? Once you give your input and you have your output, right? Now you want to compare how close your predicted output was compared to your ground truth, the closeness between these two, right? And how you do the closeness? You compared how many words you have got right in this particular scenario. Your 10, there were 10 word in your input. Your original conversion of this text would have, let's say, 8 text. And let's say this is also predicting 8 or 9 text. So let's say it is predicting 10 of them, right? So you will compare if your ground truth has a word, if that word is there in your output, the prediction, right? If that is there, you can validate, okay, there is this one word. If you have the second word, you can say, okay, there is also the second word. You note down how many correct predictions you had made in this particular scenario. That is what my precision is, right? How much you were close to the accurate answer that you would have got. So this is one method of evaluating. Another one goes as recall, like um, how many words you got that were not wrong, right? You can come around that as well. So these are some of the method, and this n-gram based method is quite popular in terms of natural language processing when you are trying to understand, or you trying to understand the correlation between words. This is a old technique now, since the LLM has popularized. It is not widely used, but this was one of the important parameter to understand the relationship between words, right? The combinations of those words. And that's how we also, the similar technique we use in the model evaluation also, and particularly for translation kind of scenarios, right? But not always you want to have the translation kind of scenarios. Your model might want, you might want to have a model which is, let's say, doing a question answering, right? It is not just translating, it is generating something which is in a question answer kind of format. There you might want to have a semantic similarity, which is again a cosine similarity, right? You might want to have a cosine similarity kind of scenario, and let's say if your cosine similarity score goes around, or put it in the chat, what is the range of your cosine similarity that you can get from any model? Okay, any more answers? Saswat says 0 to 1. Okay. Chaitanya says 0 to 1. Anybody else? Do we have any more answers? Can it go more than 1? Can it go less than 0? There are only 2 people. That's strange. Okay, Reshma says 0 to 1.
It can go to -1 to 1. Na? Cos theta value can vary from -1 to 1, I think. Is that correct?
No, it's not cos theta, it's cosine similarity that we are trying to calculate in this
But
scenario,
we are
and it
finding
is
the cos of the angle, right? I don't know.
no. So we are trying to find out the if you go into the technical the formula of it, this is the dot product of the two vector divided by the magnitude of the vector product of the magnitude. So the range of this cosine similarity is always between 0 to 1, 0 being uh, like completely opposite or not close at all, and 1 being overlapping to each other. So it's like you have one vector here and the second vector is also on this, and 0 means they are completely not similar at all, right? And this is used for the comparison part, right? So that is my cosine similarity or semantic search. When we say cosine semantic search, and semantic, so whenever the semantic search comes in, it is about the cosine similarity that we are trying to do, right? Then we have LLM based evaluation. LLM based evaluation as in you have other LLM which for which you give the okay, this was my input, this was my expected. So you give a question, you give a expected output, and you give the predicted output. And your LLM will classify whether it was accurate or not. Let's say it will score between 0 to 1, or it will score between 0 to 10, or it will score yes or no, right? Whatever you make the model to do, it is like LLM based. You are making your LLM and you can run it in the loop, and your LLM will be producing all those results, right? You can do that. Then you have certain scenarios where, so this can be for the scenario where you are generating text, but let's say you are generating the code, right? For code kind of scenario, you do not want to have a cosine similarity, right? Or the large language model might not be the best mode of evaluation in this particular scenario. But since you are producing the code, why don't you just take it and run it? If it is able to run, if it is able to produce the result the way you want it, you are good. You can say that okay, this response was correct, and we can classify it as a good result, right? If it doesn't, we can classify it is not a good result. But next to that, you can also have some syntax correctness, whether the code that was generated was there any syntax error or was it good, right? You can also evaluate on that parameters. You can do that. And for RAG kind of scenarios, right? How many of you understand RAG? Maybe put it in the chat. What is the full form of RAG?
It's a retrieval augmented generator.
Yes, that is correct.
So
Or rather, I should ask how many of you do not, or how many of you are hearing this term RAG for the first time?
so basically, it's a two things. One is a retrieval, like through the LLM, I am getting a document, image, text, or PDF. That is a retrieval, and on those documents which I retrieve, I'm generating
Mhm.
a new content
Yeah.
using those documents.
Yes, correct. So yeah, we'll discuss all this in detail in a further session. But for that kind of scenario, it's like you are asking a question from a model, right? And you are giving, you have a question, right? You have retrieved context, and how we are retrieving it, we will discuss in detail. But you have additional context for that. Let's say you are asking, um, um, why was the third battle of Panipat fought in Panipat, right? If the model do not have any context, it will be producing something which using the knowledge for which it was trained. Or let's say forget about that. You ask something that is from yesterday, or you ask something about specifically about yourself, right? The model may not know, right? So you add some additional knowledge, you augment some additional knowledge to the model so that model understand, and using this additional knowledge, model generate an answer, right? So you want to validate whether this answer was correct or not correct. So there are certain parameters of evaluating this is like faithfulness, answer relevancy, context relevancy. These are some of the parameters that goes inside evaluation of the generation that the model has done for that particular scenario. Or if you are fine tuning a model, you want to validate whether your output, that the output that has been generated, whether it was correct or not correct, right? You might want to validate that as well. I have provided the link as well. You can go around, maybe read a bit more on model evaluation as well, right? So I'll be sharing this document. Do we have any doubts still here? We'll be moving further. We have some interesting things available further.
Yeah, with just a question, like, we also going to go through with the like new techniques like agentic RAG or CAG and
Yes,
agents.
yes, we are going to go through some of them, not all of them, but yes, we are going to go through some of them.
Okay, just I have a confusion between the agents and the RAG, like
We'll
in
come
the
there.
near. Okay,
Yeah.
okay,
Just wait for another 1 or 2 session. We'll come there.
okay.
Okay. Okay. So any doubts still here? I'll proceed next if you do not have any question. This was the session that we were trying to finish up from our yesterday session, because yesterday session took half our time from our earlier session. So we are lagging in that terms. But we'll make sure that we cover or we discuss each and every topics that we have there in our agenda list, right? So let me pull up another document. I'll be sharing this document with you guys. You can have it from your learning portal. Yeah, so we'll be discussing in detail now about RAG, the same thing that we discussed 2 minutes ago. We'll be discussing this in detail in today's session, right? And this is one of the, I would say, important topic, important use case. You can build multiple use case around this. The core remains more or less same. There can be changes in different part of different segment in this particular architecture, but more or less things remain broadly at the same level, right? So what is RAG? Abhi, I think Shashwat or I think Samsher explained the RAG, right? I'll discuss it again. So what is RAG? As the name itself suggests, yeah, I'll just put it in full window so that we can have more space to write. Yeah. So as the name itself suggests, we are generating something. What we are generating is the same as what our language model generating the next token. We are predicting the next token. So it is generating those next token. But these next tokens are not same as that we had in our large language model. They are more contextualized. They are more biased toward the knowledge that we are augmenting or the extra context that we are providing to the model, right? So it's like the model is it is a large language model. It is a use case around large language model. So it is going to generate something, right? How it is generating? It is not using uh, all of his knowledge bank. We are using the model capability, or we are using it the model capacity to predict the next token. But we are augmenting the knowledge for the model. We are not relying on the model for the knowledge. We are adding that knowledge for the model, and the model needs to uh, uh, predict something that is the next token that is the model do, right? So we are augmenting, right, to generate the model, right? How are we augmenting? We are doing some retrieval. We are doing some sort of retrieval from some sort of database, and we are augmenting that information to the model. And the model, the ultimate task of the model is to generate based on the context that is provided. This is all about RAG. How we going to retrieve? How are we preparing this database from where we are going to retrieve? How are we augmenting that knowledge? How relevant that knowledge is? How we are going to generate that? There can be different topics of discussion that we'll be having today. But more or less we are retrieving something, we are augmenting this knowledge to my large language model when it is generating the next token or when it is generating the response, and then it is generating the output for the user, right? So in this, we will be having some topics like vector databases, right? Because we need to retrieve something. From where we retrieve it from vector database. We have a concept called chunking, right? We have something called embedding, right? We have something called similarity, right? So these are some of the, and we have something called prompt. I hope till now you guys are practicing around different prompts, how you can write to the model, how you can expect a better response. Because in this particular scenario, we'll be using a simple prompt that model needs to use the additional knowledge to generate the output, right? But before we get into the working of this model or the internals of this model, let's see the model in action, right? Let me pull up my screen. I have already running. I have started it before we started the session today, right? So just tell me what I'm doing. How many of you are able to understand what I'm trying to do here?
So
How many of you, just let me finish this and then you guys tell me what I did. I know what this error is because this is what I changed. Let me fix this. Yeah, I'll just refresh this. I'll paste my API key. How many of you know what is API key and how to use it?
so API key is give us authorized access to get the access any application or any portal. Like if I using a OpenAI key, so it will give me access, authorized to access the
Yeah.
OpenAI code which is
Yes.
open for.
So I can use the API key so that OpenAI knows the request from where this request is coming in, right? And I can pass my request, I can pass my data, I can use the model that they have hosted, and I can consume the information. So it's like for inferencing, I'm using the API key in this scenario, right? What document I'm using this. Which model I want to use, let's say I want to use GPT 3.0. And why I have used particularly my resume in this particular scenario is because my information on the internet might not be available, right? Not accurate. It might be in some broken format, not all at one place. But I want to show you that I'm passing in some custom information. I could have taken some random document from the internet, right? But or like any other document that I can have. But this is just to show that this is the custom knowledge that is going inside and the model is producing the results, right? Let's say uh, I'm trying to ask about the projects, right? And internally, it is currently configured at a very basic level, not too much of optimization done. It is just a very basic you can expect, right? So see, these are some of the projects that are available in my resume, and it is coming
So,
from my resume. Yeah.
so basically, you have done, the RAG implementation, RAG model
Yes.
implementation.
Yes. This is what we are going to understand how it is working in the internals, and we'll be building a use case around this. We'll be building the similar kind of application for each one of us. But I would want everyone to participate. Everyone's to do the hands-on, right? Let's say I ask a different question. Um, let's say if it is able to answer this question, because this information is specifically in one particular line of the document. See, it is able to capture that information. So this is coming directly. If you ask this question around the internet, you might not get this accurate answer, right? But since I am augmenting the knowledge of whatever the knowledge that large language model had till the cutoff period, I'm using the model's learning capability and passing in my information. I'm passing, let's say I'm telling you, okay, this is the document, answer this question from this document only. And then it is generating the response. Does this sound interesting?
Yeah.
For how many of you this is interesting to build? And how many of you are ready to build it with me?
Yes, of course, we will.
You
Rest.
using Gradio or Streamlight for this? Gradio.
I'm using Streamlit for this.
So, Ankit, so
Mm-hmm.
in this, by using a RAG model, we can create, the application or a system which create a code itself, just putting, the given complete information. Like if I use a Python library,
Uh-huh.
use as a Python library and give a info or any the model, right?
Mm-hmm.
GPT model or any other model, and give a kind of a query that this kind of I required a kind of a function, a specific function in the detail. So it can create my method into that.
It can create even now. Like even if you give the GPT model or any OpenAI model or any other open source model also, if you
Uh,
ask, it will generate something.
yeah,
But it
it's
is
generated.
particularly helpful when you have a custom knowledge from where you want the model to respond.
Okay.
See here, this
Yeah.
document only PDF we can do. We can upload Excel of some KPIs and can be query on that
Yes,
in
you
this
can do
same
that.
model
Yes, you
or
can do
see
that. It's just that you need to configure internals according to that. I
ha
have
ha.
built
That's
use
what I'm
cases
saying.
around where you can just upload your
Here you will be using the
CSV
chunking
Excel.
and all.
Yes, there the
Here you have
processing
to
will different.
text to query and all we have to use, right?
Yes, correct.
So like
So will change.
there
Hmm.
are many documentation available which is related to domain. Like if I say in the insurance domain there are multiple certifications.
Uh-huh.
You need to know like Llama 36, 380, 390, 370, and many others. So if I provide this kind of a document, so I have a specific customized application which give me a complete knowledge on the domain itself. Like if if I want to ask, okay, what is a claim particular claim process in PNA case, property and casualty, PNC,
Uh-huh.
property and casualty. So what would the claim process needs to be, or what would be the workflow kind of. So these kind of things we can implement in the application by using a
Hmm.
RAG model.
Yes, we can build that. Yes, that are these are some of the use cases that we can build, and we should build since we are learning. We should experiment around different use cases that we can build, and we will be discussing how we can improvise. Currently, the setup that I have built here, this is for very basic chunking strategy. I have used very basic model. I am using very basic prompt. I am using. I'm not using too much of fancy stuff inside it.
Right. Right.
Even then, it is able to work pretty well, right? But if the complexity of the document increases, if the information is available or spread across the document, this might fail, right?
Yeah.
Depending upon, so this strategy, what kind of chunking strategy would use, what cleaning you should do, what model you should use, depending upon the use case, completely vary on your use case, right? We will discussing how we can optimize it. But how many of you are excited to learn this part particularly? I was very fascinated when I learned this, and I built multiple use cases. Put it in the chat how many of you are excited to build this particular use case. And let me share the code also. The code is not like too much of code in behind this. Let me pull this up. Can you see this?
Yes, yes.
So particularly on the left hand side, if you see, this is my one notebook, which is app.py. This is primarily just for the UI part that I have mentioned here. No, Streamlit. I am configuring it on Streamlit, right? So I am putting some basic simple UI layer on it. The left part of the screen, this notebook app.py is currently just controlling that part, how it should come on the UI. I need a left panel. What should be in the left panel? You can enter your API key. You can upload your notebook. You can click on that button, right? Some process will trigger at the back end. Once while the process is triggered, there should be some message on the screen, right? That's all we see. So this is configured in here. But what is happening in the back end? The technicals of it. When you click on a particular button, what is triggered in the back end, right? On the left hand side, I'm just calling whenever, let's say if I show you, uh, if the query is available and if the user places a submit button, this process should trigger, right? This will get the relevant response. This get answer is available in my different notebook. Everything, all the technicals is configured on my right side of the notebook. How I am taking the document, how I am processing the document, how I am breaking the document, how I am cleaning the document, how I am pushing it to my vector database, how I am retrieving the information from my vector database, how I am putting it together, and how I am asking the model to answer, right? Everything is configured on my right side. So this is a good practice whenever you are building this sort of application. Try to segregate the code based on the use case. If you mix up everything, you can build this all of it in one single file itself, but it would be difficult for you, right? If you want to use the same UI for different application, you can just take it from here, copy paste, start using it. It's not that you cannot use the code. You can use the code, but it's just that you should be able to understand what is happening in there. There are Python community is quite open source. You can use the code. It's just that you need to build the use case, right? So I'll be sharing this notebook as well to get started with. You guys can pick it up from here. There are some configurations, something that we will be discussing how to run this notebook. Uh, just want to understand how many of you are handy with Streamlit, or rather, I should ask how many of you are hearing this term Streamlit for the first time? Streamlit or
I
Gradio?
have I have created a very small, like, just given a prompt, getting, click on the button, and that's used. Streamlit basically used to create a page, like, we use a React and
Mm-hmm.
other programming language. So Streamlit create a, we
Mm-hmm.
can create a web page like this one. You have
Yeah,
created like a Streamlit. So it's quite even I have a very small experience into Streamlit, but what I found is it's quite, interesting and much easier to do that, because if I need a button, there is a completely a button method is available. Just use
yeah,
Streamlit and
because because for our use case, we don't need fancy buttons, fancy page. We just want just enough so that we can showcase our use case. If you go ahead and showcase your use case to anyone in your notebook, in your Python script, or in your terminal, it might it might not make sense to everyone, right? But
yeah.
if you put a simple UI, you just write one with streamlit.spinner, you will get something. Streamlit.input, you will have an input box there. You don't
Yes.
need a fancy UI there, right? So that's what for Streamlit is. We'll be using the Streamlit. You can use Gradio if you want to, but I am quite handy with, I'm comfortable with Streamlit.
Hello.
That's why I use Streamlit.
This code
Hello.
you written fully, or you take the help of LLMs to
No,
get the
this
code.
is something that I have written myself. I'm using, so I will be discussing how I have written, what are the different.
Is there any way we can use some tools like Cursor or maybe Cloud
If you
AI or
want to use,
somewhere?
you can use. That's completely up to you. If you want to use Langflow, if you want to use Crew AI, if you want to use Cursor, if you want to use GitHub Copilot, completely up to you. But you need to understand what is going to happen underneath. When you are going to click on something, when you are connecting something with some other thing, you should be understanding what is happening. Or when you are generating a code with the help of any AI tool, you should be able to understand what is happening, because tomorrow your function will be so bigger that fixing it where it is, what it is, sometime AI might not help you, right? So the only thing, and if you are like, "Yeah, I can use AI," yes, you can use AI, but there are n number of people who are using AI. How different you are from all of them? So you need to understand the code. If you are afraid of coding, maybe start little, slowly start picking up. You take help from AI, take help from your friends. Uh, Saswat says that he is very new to Streamlit. Reshma says that she's not familiar with the Streamlit. But Chaitanya says that he is used to with Streamlit. So maybe you can collaborate and share your learnings across, so that
Uh,
others are also able to pick up it faster, right?
Ankit, have you tried this? That creating a your form design on a paper, click the picture and upload it on the Chat GPT and ask, this kind of a design. I need a code from the Streamlit,
Yes,
because I have just get this thought. Or maybe tomorrow I will try this. That create a one
yes,
simple.
you can do that.
So
I'll
I
be
get
sharing this code. I'll be sharing this code. Don't worry. I'll be uploading this code. You can use it, and you just need to configure your environment variables, and you should be able to run. I'll be uploading the documentation around how to use it as well. Okay?
okay.
Yeah. Shall we get
But
started?
there's a one question, coming into my mind, like when you work as a Gen AI engineer or AI engineer on any
Mm-hmm.
organization, okay, and you are working on some projects. So at that time, you take a help from the Chat GPT, so increase your work. Like if I need a do fine tuning of my current LLM, whichever I'm using. Let's say I'm using Claude with the help of LangChain framework,
Uh-huh.
okay, and I'm doing a fine tuning. So is it fine to work in such a way that if I need a help, I'll take a Chat GPT, understand the code the Chat GPT provide,
Yes.
and then
Mm.
modify that
Nahin,
code
okay, I'll tell you my experience in my
yeah,
organization. My CEO encourages us to use AI tools to generate your code.
okay,
He
okay,
encourages us that why are you not using the tools that are available in the market? Your time should go in building the logic, not building the code,
right,
right?
right,
You should be able to understand, okay, what has been generated. Because ultimately, if something breaks, you need to come and figure it out, right? You need to fix it if something is breaking tomorrow.
right, right.
But first draft, generate the code with AI, use it, modify it for your use case, and proceed further.
Like
Don't
like in
generate
the
it blindly. Huh.
like generating the deep learning model code, and change the optimize,
Yes.
doing the fine tuning
Yes,
by
understand.
adding triggers
Understand
and
what is happening, why is happening. Correct.
hyper tuning into that. So
Yes.
different values. So the different values, the output will be different, and what would be the best, we will get it. Okay.
Yes. And for that matter, I'll give you an example. So I was interviewing one of the candidate for my organization, and
Mm-hmm.
we had this open, like if you want to use AI tools, you can use AI tools as well.
Okay.
It's not but you should be able to understand if the code that is generated with the help of AI tool, you should be able to understand what is
Right.
happening there.
That
You
is
should be
important.
able to debug it. You should be able to explain what has happened, why it did what it did.
Okay.
Yeah.
Sure. Thanks.
Hmm. Okay. Shall we proceed further?
Yeah.
Okay. So we'll be learning why do we need RAG sort of architecture, right? First of all, this is the most important thing, and this was one of the question that was quite in limelight till 1 year ago, 1.5 years ago. Now I don't hear this question quite often, but this is one of the important question when you start learning the AI sort of application, or you start learning this use case, right? So let's say take a scenario where you have an input document which is of 10 pages. right? 10 pages, you extract this information, you have 5,000 characters. Shit, ये क्या हुआ? See, right? 5,000 character. Right? Right? And you want information from this 10-page document. But this document can be anything, right? Let's take for example, right now it is something about India's culture. It's a diverse document that it has, and it has around 5,000 character, or maybe more than that. 10 page can have more than that document. Like, let's say it is 50,000, right? It has 50,000 words, not characters. Just a hypothetical scenario. It can have more, it can have less, but just for an example, right? So now you want some answer from the document, right? And let's say this document is something which the information is not openly available. The model may not have information what is there in this document, right? It does not have that knowledge. So you want to add this knowledge to the model. And let's say you ask a question and you put this complete 10-page document. This is going to be my augmented knowledge, right? And you ask the model to generate answer, right? From the question, you are augmenting the 10-page document and you are asking the model to answer. What do you think is a problem in this particular scenario? What could have happened? Is it possible that the model will give correct answer? Is it possible that model might miss certain information that it needs to use to answer the question, right? Think on the prospect that for each token that you are giving in the output and for each token you are giving in the output, right? There is some processing happening. There is some cost for each processing that is happening. If you pass this 50,000 words in the input and this break down to, let's say, 15,000 tokens only, 50,000 tokens, you are processing those 50,000 tokens, right? Think in terms of resources also. Is it efficient? Your information might be there on the first page itself. Let's say first page, first paragraph. Even after when the information was available in your first page, first paragraph, you are scanning through the whole document to get that information. You are making the model understand the whole document, search for the information in the whole document, and get you the answer, right? This may not be the best way, right? Are you getting what I'm trying to make you think in this particular scenario? Your information was available on the first page. Break the document in the first. Yes, we will come there. Sashwat will come there. Just the next thing, but just we are trying to understand why do we need RAG sort of architecture, right? So since your information was available on the first page, um, I want the model, or let's say if Shashwat says that we break the document, okay, we pass one document, but how do we choose which page do we pass? We have 10 pages, let's say in this particular scenario. How do we, let's say if the information was available on first page and third page, right? So you mean to pass, how do we choose which page to pass, which page not to pass? That is again a question, right? But let's say there was the information was available in one particular sentence. In this, even if we send, let's say, okay, I'll send only first page. Even in this first page, the information was available only in one sentence, right? For processing the information that was available in one sentence, you are passing one page of information or 10 page of information, right? There are chances that model might miss that information that is available in that one line, right? Because the model is processing too much of information. Do you see the problem in this kind of architecture? So it is not efficient use of resources, the input and output tokens if you pass this. So why do we need RAG? Because we don't want to process the whole document at one go. And every time when a user question comes in, we are processing the whole document again and again and again. This is not the efficient use of resources. Plus, if you are passing additional unnecessary information more to the model, there are chances that model might start hallucinating and you might not even know when the model is missing on the answer, when the model is giving you the correct answer and all that part. And hence you can have a impact on your accuracy. on the accuracy of the model. If you give just enough context to the model to answer that particular question, you might get a better answer. You can expect the model to answer better compared to when you are giving the whole document, right? You understand why do we need RAG now? Put yes in the chat if you understand what is the use case of RAG, or why do we need RAG kind of architecture. Yeah. Okay. Great. Thanks guys for responding. So let's move further and let's see what is RAG architecture. When we say we are discussing RAG, what is exactly inside the RAG? What are different when we say architecture, what is the RAG architecture internally? So this is a picture. I have taken it from the internet.
Okay, just a
Nothing of a,
question.
yeah.
Uh, what does the meaning of the augmentation
Okay.
in React? Like I didn't get the
Yes.
augmentation.
So augmentation is augmenting something, augmenting the knowledge to the model, or providing context, or I would say enough context.
Like that part we are doing in the retrieval. So how
You
augmentation?
are retrieving that information, but are you passing that information to the model? When
Okay.
the model generates the answer, the model should have that information. How we are retrieving that information, that is dynamically coming, how we are going to configure that. Once you have that information, you are passing that information to the model. You are providing it as a context for the model to understand the question better and respond accordingly.
Like do I understand correctly? Like concatenate or merge, consolidate the retrieval information and the query and pass it to the
Yes,
LLM. That is what
yes, correct.
augmentation
Okay,
does.
yes, this is how you will write the prompt. Okay, to answer the question, use the context, and then you provide your context, whatever the information is. Now answer this question, or let's say you say question this is, and write answer, and then you wait for whatever the answer will come from this information. You can also mention if the information is not available in the information, say don't, I do not know, right? You can also pass this kind of instruction to the model. This is what my augmenting the additional information is, and this is how I'm writing the prompt. The prompt become an important part in here, because prompt is something is the complete information the model will understand of what you are trying to do, of your use case, how to use that additional information, what is the task, what is the role that the model needs to play in that particular scenario, right? This is where the prompt becomes important. Does this make sense?
Yeah.
Great. So this is the architecture of my RAG. Broadly, there is certain part which is my document. The document comes in the input. It can be PDF, it can be a text, it can be any kind of, it can be a speech, it can be a video, it can be anything. You extract the information that you want to process further. Extracting the information, again, there can be a number of methods to extract that information. But once you have extracted that information, the game begins, right? You break the document, the input information, into smaller pieces. That's what we are calling here document, or we can call them chunks. We will understand what the chunk is, how to break the document later. But you break the input information. Let's say you have 10 pages of document, right? You break this document, let's say one page. So you will have 10 different document, or let's say 10 different chunks. I'll call this as chunks from now onwards. Okay. So you will break this 10 pages of document into 10 different chunks. Each page is one chunk, right? So once you have the chunk ready, you are embedding this information. The information that is available in one chunk, you are converting into embeddings, right? So now you will have 10 embedding vectors available with you. But you can't just keep them with you, right? You can't just store them in a variable. You want to use it later on when the query comes in, right? So let's say you are putting them in a vector database. There are different databases out there in the market. You are storing the vector, plus you are also adding some identifier. which you may or may not want to. Not necessarily you want to add that information, and this information, this identifier information, or you can call it as a metadata, the metadata of that particular vector, which has been the information that was converted to vector. Let's say you want to add metadata as page number, or you want to add metadata as, let's say, what does this document belong to, because these all 10 documents, let's say, belong to one single topic, so you want to add topic. Let's say you have 10 different topics like that, and you want to add it one single topic around that, right? So you can use these kind of information to filter later on. So you want to have some metadata along with your actual vectors, right? So this is all that we set up before your model or before your RAG is ready to answer the question dynamically, right? This is all the setup part. Now, once the user query comes in, you use the same embedding model to convert your natural language query into embeddings. Make sure, and it is 100% to be done, that whatever embedding model that you are using while converting document to embedding in the initial phase, you are using the same embedding model to convert your query for the embedding, because we are going to do the similarity. If, let's say, your embedding model here was OpenAI ADA model, and here you are using BGE3 model, right? Yeah, all mini model, you are using the different model. So how can you do the similarity between these two? No, it would be difficult, because you have array of different sizes. You cannot do you can perform the cosine similarity over there. So it is required that you have the same embedding model in both the scenarios, while you are preparing the document and when you are converting the query into embedding. Use the same embedding model. Once you have the embedding model, you retrieve the information. See, you retrieve the information. Let's say you want to retrieve the information based on the user question. What was the important pages, or which has a higher similarity in your database for the current question? Let's say whatever the user question was, the information for the document was available on page 1, right? So page 1 would have a higher similarity compared to any other page in your vector databases, right? Compared to any other chunk. So you want to retrieve that information from your database. Only the information which is relevant for your scenario in that case, right? You have that information and you augment that information with the question, and you ask LLM to answer. Now LLM will have your question, LLM will have your extra knowledge or the augmented knowledge, right? And you are asking for the model to generate the response, and the model is giving you that output. This is the architecture at a broader level, what the RAG architecture looks like internally, right? We are retrieving here, we are retrieving. This is where the retrieval process is happening. This is retrieval. Here we are augmenting the information, and here we are generating the information. So this is my R, this is my A, and this is my G, right? Does this make sense to you? This is a broader architecture. We'll be discussing this part in detail. We'll be discussing this part in detail. We'll be discussing this part in detail, and then the response will be generated. These are all static. The embedding model, which embedding model you are using, which vector store you are using. There are multiple vector stores as well. These are all static, but on a broader level, this is what is happening internally. How many of you are able to understand the broader architecture of the model? Then we can move to the individual topic within this architecture. Shashwat says understood.
I have a doubt. Suppose the user query doesn't have the information, I mean, the query is not related to the document. In
Okay.
that case, what would be the answer? Like whether LLM itself provide the answer from its knowledge base, or
Okay. So now that goes on to your prompting. How you are prompting. Let's say in your prompt itself, you say that if the question is outside the context, you can deny the response, right? Or you can say, I don't know. It is up to how you structure your prompt. Sometimes, if the user wants to do prompt injection, there is something called prompt injection. you might want to control how the user input will come in, how you can handle that user question. Sometimes the user question is very open-ended and very, you know, out of the box, which the model do not understand, right? You can work around that and see if you can get a document which is of context. If it is not of context, there is also something called re-ranking, which we will be discussing on how you are improving the response. If the model do not have enough context to answer this enough augmented knowledge to answer the question, you can mention that, okay, we need to say, I don't know what you are asking, right? Or you can say, use your knowledge to generate the response in that scenario. Does this make sense?
Okay. So
Yeah.
in that case, like we would be providing the prompt in that way, right?
Yes, you will be asking, because that's the instruction that you are passing to the model. You'll be passing the instruction in such a way that if the information is available in the additional context that is being provided, you need to provide the answer. Else, you can say, I do not know.
Okay.
Yeah, we'll be looking into so the demo that we have seen a little while ago. We'll be seeing what was the prompt that I have used internally. There are some standard prompts already available. You can use some of them. You can write your own prompt as well, right?
Okay.
Yeah. Do we have any more questions, or shall I proceed? Okay, so I'll take the silence as we understood this architecture, and now we'll be proceeding further and getting into the details of the topics, right? So let's start with vector stores. You saw the vector store is here in my architecture, right? So we'll see what is vector store, how it store the information, and how it handles that the whole thing, right? So how many of you knows about other databases, and how many of you heard of vector databases prior to this?
We are using Quadrant.
You are using Quadrant, great.
Yeah, vector DB.
Hmm. So vector database, so audit like conventional databases, you can store any kind of document like PDF, images, your relational databases, your unstructured kind of databases, right? You can store anything and everything just like you are dumping in your local system. But your vector databases are particularly designed or particularly configured to store the vectors. Vectors are just a array of numbers, right? And they are designed in such a way that you can efficiently use the vector database for your use case. Yes, because whenever you are retrieving something from this database, you are not just retrieving anything randomly. You want to retrieve something which is closer. You always want to have some sort of similarity kind of scenario. Sometimes you want to retrieve everything and anything based on some, let's say, filtering, or let's say everything for your use case. You want to see what is there in my database, but generally you want to have some sort of cosine similarity, and these vector databases are optimized for that kind of scenario, for doing the cosine similarity. Right? So this is the use case, and it is easy to manage all those vectors. The database or the vector can be of different size, like 384 that we saw for yesterday for BG embedding. OpenAI 1536 can be there, 1024 can be there. So these are different sizes of a vector. You can store that vector n-dimensional array into your vector database efficiently for retrieval, efficiently for storage, right? If you store these vectors, you can store these vectors in your conventional databases also, but that is really not the optimized or the efficient way of storing all this information. When you are retrieving it, you are doing another calculation, which is again intensive. So vector database are specialized databases, particularly for vectors only, right? And this helps in the efficient retrieval metadata information in each vector, like your table name, your column name, if you have any, let's say you have a page name or page number, or let's say you have a book name, right? You can store some additional information, and this additional information can help you filter the vectors that you have put in. Let's say in the application that we saw just a while ago. Yeah. In the application that we have seen just a while ago, how many of you noticed that I had a drop down? Yeah, I had a drop down where I was selecting the document, what document that I want to search for.
Yes, we saw.
Yeah.
You are
So
yeah.
I was using the drop down to filter the information. I can upload 3 documents at the same time, and I can use which filter to apply from this drop down, which document I want to search this query on, and then I can proceed further. So I'm using this metadata information to filter the vectors that will be used for that particular scenario. So it's like first I'm filtering, then I'm doing a cosine similarity, and then I'm retrieving the information, right? So that's what my metadata is helpful for. And metadata is really helpful when it comes to the use case, building some sort of applications, right? Then what are some of the examples of common vector stores that are out there in the market? Pinecone is the one that I have used in today's demo because it is free, it is easy to deploy, it gives me one index. You can try that, but you can use other databases also. I would suggest trying some other one. You will encounter some error, you will understand how to debug them, how to use them, right? Pinecone is the one. ChromaDB is by I think Microsoft. Then we have Faiz. Faiz is from Facebook. Then we have Quadrant. Quadrant is some open source. This is open source. These all are open source, by the way, except Pinecone, right? Quadrant is also open source. Then there are some Weaviate vector store, which is also quite popular across the industry, right? So these are some of the famous databases. Internally, they're storing the same thing, but how to use them is again Pinecone itself has its own documentation, right? Of how to use this vector, how to upload your data, upload your vector into the Pinecone vector database. Chroma can have its own documentation, Faiz can have its own documentation, but again, we will be using LangChain. LangChain has made our lives easier when it comes to handling the vector databases or handling different models, right? So we'll be using LangChain ChromaDB or LangChain Faiz or LangChain Quadrant for these use cases, right? And even LangChain helps us. You just give the document which needs to be converted to vector. Let's say for this scenario, let's say you have one line of statement which needs to be converted to vector. You give this one line, you give the embedding model which you want to use to convert this to, and you give the metadata information, and that's it. Converting it to vector, putting it into vector database, attaching those metadata information, everything is configured, everything is taken care of by LangChain for you. So LangChain is really making life easier in terms of building a use case around this and making it dynamic. So if today I'm using Pinecone, tomorrow I want to go with Chroma. It happened in my organization. Earlier we were using Faiz, but then we hit some limitation of using Faiz. Then we switched to Chroma like around 6 to 7 months back, right? And we were using Chroma till very recently, and this current week we are making changes and we are moving toward Quadrant, because Quadrant, the functionality that is available in Quadrant is not available in other vector stores like Chroma and Faiz. Pinecone provides that, but there is something called hybrid search, which is not available in Chroma as well or in Faiz as well, right? Hybrid search is a little, I would say, on the advanced part, which if the time permits, we will be discussing later. But for your curiosity, you can explore, and this is a really interesting thing as well, interesting topic as well. Okay? Yeah. So I think we are already about the time. If you guys have any doubt, please shoot at me now.
I have a doubt, Ankit.
Mhm.
Um, this does this vector DB resides in LLM model or it's outside of LLM?
It is outside of LLM model. LLM
Okay.
model has nothing to do with your database. It's just that you are storing your information. You can use any embedding model, irrespective of what LLM you are using. They are completely independent.
Okay, and LLM and vector database can interact with each other using LangChain, correct?
No. So you
Okay.
can configure your vector database using LangChain. You can configure your large language model using LangChain. You
Okay.
want to change the vector database tomorrow. Today you build, let's say, on Chroma. Tomorrow you want to move to Quadrant. You need not to change your internal code at each and every place. You just need to update the object of how you were using. Did you see
Okay.
yesterday when we were using
Right.
those embeddings?
Right. Right.
If we keep on changing the models, or if we are experimenting around the model, we don't want to go back and change our whole code based on the use case, right? We just want, we'll change at one place. This LangChain is providing us that wrapper. If a function, let's say, this object dot run, what object dot run is doing for Pinecone, same thing is doing object dot invoke in Chroma. Internally, if I'm trying to invoke, I am using a singular language to interact with all of them. And when I say singular language, singular methods, singular functions that are used for that particular process to trigger, right?
So there should be some API available to fetch the data from vector database and send it to LLM,
Yes.
right?
Yes.
Okay.
So when you are configuring your database, depending upon where your database is, if your database is in your local, Pinecone cannot be in local. Pinecone is a private point. If you have a Chroma, if you have a Files, if you have a Quadrant, these are databases which you can have in your local machine, right? You
Okay.
need not have a API key around that. But if you are using Pinecone, you might want to. You need to have a API key. You need to have to call the Pinecone object. You need to create that. You need to set up all that scenario.
Okay. Got it. Thank you.
Yeah. Yeah. No worries.
Just a question, like you just showed a demo of your use case of a document.
Yeah.
So you are uploading the document at the real time and using that
Yes.
document for the chat.
Yes.
So you are not storing that document embedding into the Pinecone or what?
No. So
It
if
converts
you
the real time embedding.
no, so what you saw, I displayed the complete end to end at one go. But there are two part of it. One is uploading the document. Did you notice initially when I uploaded the document, I pressed the button and it took a couple of seconds to configure the backend, right?
Yeah.
Wait, let me show you if I can. Did you see this left part? I am pressing it here, push the bot to learn, right? When I click on here, it will do that processing. It will break the document into smaller pieces. It will convert them into vector. It will put them into my vector databases along with the metadata information that I have configured, right? Once this is ready, the right part of my notebook activates. The right part is on the consumption part. So this left part is something that I can put it in the internal, already configured, already set. User need not to worry about those. You just come here on the UI part on the right side of it. You just put in your question and you start asking. So when I am asking a question, I'm not bothered about how my document is being processed. I'm not processing. I'm just retrieving the information and augmenting it and generating it.
Okay. Got it.
Okay.
How this vector database is used for numerical data? Is that used, or it is we use
No.
our
So
normal database for the
So
numerical data?
when you say numerical data, what do you mean by numerical data? Can you explain that?
It can be an Excel or CSV or any data which
Okay.
is it's a KPI. It's a KPI or any sales data, something like that.
Yeah. So particularly vector databases are, so if you put your Excel in your vector database, you can try that, but that is if you go and try to convert numbers into vector, you might lose the relationship between those numbers, right? When you have a Excel, each column, each row has certain meaning, right? When you are putting it
Yes.
into vector, that meaning might get lost, right?
Yeah, but
And
see, ideally you are speaking, we don't use vector database for numerical data processing,
correct.
analytic.
Yes.
If I am building a numerical analytic bot, okay,
Uh-huh.
I should not use vector database.
Yes. For numerical or Excel or I would say structured document,
See, it's a
vector
similar
database is
query.
not the.
If I am making similar instead of PDF, I am uploading a CSV or Excel file.
Uh-huh.
Okay, I am, and then I want to derive some insight or a chart or something from that data. So
Mm-hmm.
I want to build a RAG or RAG. Okay,
No.
for that.
So if you are building a use case around structured data, and it is okay for you guys if I take like 5 minutes, we are into the discussion. If you guys wants to drop off, you can. We won't be discussing any new topic now. Okay. Thanks for joining in. I'll be discussing some of these points now. Okay. So
Yeah.
for structured data, the use case is completely changed, or I would say not completely changed, but the retrieval part completely changes. Because for structured document, you need not to retrieve the way it is retrieving right now. Let's say you have, or let's say in our scenario, how we are converting text to SQL and it is for enterprise, we might have 100 of tables, right? We might have 50 tables, we might have 30 tables, we might have 200 tables, we might have. So one of our client recently has around 300 odd tables in their database, right? And they are all connected and everything. There is a whole network that is created internally in their database, right? So what we need to do for the user question, particularly for user question, let's say your question was coming from two tables only, right? So we retrieve only those two tables from the database. We take the schema of these two tables. We pass this schema to the model and ask the model to generate a SQL query for that particular scenario, right? And then we have the SQL query, we hit it on the database and we get the output. Sometimes the query may not be correct. Sometimes it might have some syntax error. Sometimes it might have error like the column even does not exist, right? It can happen. We do encounter this kind of scenario. But the retrieval part here changes. In earlier scenario, our target is to generate a response. When we are going into the Excel kind of scenario, we do not expect model to give me the direct numbers. We might to have some additional pipeline as well, which is first converting my natural language text to a SQL query, and then using that SQL query to hit my database and get the numbers, right? So this is like process broken down into different buckets, which are running in a pipeline, which are running integrated into a single pipeline to produce the response for the user. Does this make sense?
So you are saying that we should convert into a SQLite kind of database
Yeah,
and then make the query out of it.
yeah, that is correct.
And that query, making query, you can use then this one Gen AI, sorry,
Yes,
LLMs.
yes. Generating the query dynamically based on the user question can be done through large language model.
Yeah. Do we have example coming up similar for that structured data? Any
Uh,
example?
so
Can
me
we
in
do at
my
least?
organization at the moment, we have built a pipeline which does exactly this. The natural question comes in, we shortlist the tables, we generate the SQL query, we hit the database, we get the response, we show it to the user.
Can we do that project? At least a prototype of that. Yeah.
Yes, we
We
can
can
do
do
that.
something like that.
Yeah. So how about mm, I have the code for that ready already. I did this project like way back.
We can share
I
also.
should be able
I
to
will go.
have.
I will try myself also. No problem. But in some time, when you get some time, you can explain that. Then it will be great.
Yeah, yeah, sure, sure, we'll do that.
If you can share the today that code, I will try to
Yeah,
go
I'll
through.
look into my repo and I'll see if I can
One,
find out. I'll share it with you guys
yeah.
across.
In that also, this query need to be validated so that there is no delete or any kind of
Yes. So these
update
are
or
new.
modify.
So when you build or when you evolve with the use case, these kind of nuisance can come in, right? User
Yeah.
can say, okay,
Are you
delete the
doing
table.
something towards that?
Yes.
That some cross-checking mechanism that okay, query is perfect,
Yes.
or it
Yes.
won't go to a loop, continuous loop or something. Yeah.
Yes. So you cannot always have a SQLite database. You might want to have directly hitting on the client data. right? Client server.
Yeah, yeah,
Your query is
yeah,
going
yeah,
on the
yeah.
client server, and we cannot
Yes,
we cannot send a delete query, right? So we
yes,
need
yes,
to have
yes.
that checks in place before we are sending a query for execution.
Yeah, that
So
is
we
also
do
there in
have,
your code, right? Yeah.
yes, yes,
So if you can share, that is great actually. At least, and we can explain whenever you get some time in between. Yeah.
yeah, sure. I'll see if I can find that and I'll share it
Mm.
across. Don't worry. Yeah,
Okay. Okay. Okay.
yeah, yeah. Do we have any more questions for today?
No, I'm good. Thanks.
Okay,
Thanks.
thanks. Yeah, thanks, Amshi. Thanks, Ashok. Thanks, Reshma. Have a good one. Happy learning. And if you guys come across any doubts, please feel free to note them down, explore, or maybe try to debug it yourself. I'll be sharing the code notebook and we'll be continuing with the discussion in our next session.
Okay.
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 Thank you.
Yeah. Thanks. Have a good one.
Yeah.
Bye bye.
Bye.